Hi, I'm Charles Langenfeld, and I'm telling you about the weather. Let's start out with Sunday, April 8th. As you know, April is a spring month, so temperatures will not be freezing or super hot. As you can see on this map, the southern part of the United States is very warm. That is because of the continental tropical and the maritime tropical coming in from Mexico. It heats up the southern coast. The northeastern and the northwestern parts of the U.S. are colder because of the maritime polar, coming from the Atlantic Ocean and the Pacific Ocean. The main front that runs through the U.S. in this map is this one right here. Throughout Canada, Michigan, and Ohio, there is an occluded front. An occluded front is when a warm air mass is trapped between two cooler ones, and the warm air mass is pushed up. When this happens, the temperature near the ground cools, and there is often rain. Then, throughout the middle eastern part of the United States, there is a cold front. A cold front is rapidly moving cold, dense air. They move quickly, causing storms, but after they pass, they leave clear skies and lower temperatures. Just in Texas, there is a stationary front, which is when cold and warm air meet but can't move each other. This could bring clouds and make it rain for days. On this map, there are many areas of high and low pressure. When there is less space, there is higher pressure. When there is more space, there is less pressure. In high-pressure areas, it is colder, which is why the high-pressure sign is blue. In low-pressure areas, it is warmer, which is why the low-pressure sign is red. During the sea breeze, which is a kind of local wind, high-pressure areas start close to the water and shift over to the land where they become low pressure. The low pressure is heated and becomes less dense. The less dense air rises and shifts over the water. It then sinks as it becomes high pressure and denser, and then the cycle is repeated again. Clouds form when water vapor is in the air and condenses to form liquid water and ice crystals. For clouds to form, there has to be two conditions: the role of cooling and the role of particles. Condensation needs to be cooling, and particles have to be present so the water has a surface to condense on. Here we have some cumulus clouds. Cumulus clouds, which are very puffy, have a low base, but can extend up to 20,000 feet. They bring fair weather. Over here we have some cirrocumulus clouds. Cirrocumulus clouds look like rows of cotton balls. These mean that a storm is on the way. There are also cumulonimbus clouds over here. Cumulonimbus clouds are huge towers of clouds that usually have flat tops. These indicate thunderstorms. As you can see on this map, there is heavy precipitation in southwestern Texas and throughout the Middle Eastern area of the United States. So, precipitation can be formed in many ways. For example, hail is formed by the wind pushing water back up into the sky, and it becomes ice. It gets more and more ice and becomes bigger until it drops. Precipitation can be caused by a number of things. After certain fronts come by, such as a cold and stationary ones, rain and thunderstorms follow. This is an example of how fronts bring certain kinds of precipitation. Wind is the horizontal movements of air from high pressure to low pressure. It is caused by the unequal heating of the atmosphere. Winds are described by their direction and their speed. Winds that affect the U.S. the most are trade winds, prevailing westerlies, and the polar easterlies. The trade winds blow at 30 degrees towards the equator. Trade winds right here. So, the prevailing westerlies blow from east to west between the 30 and 60 degree latitude. The polar easterlies sink to lower latitudes and shift west by the Coriolis effect. The Coriolis effect is when winds go into the earth, but because the earth is spinning, they don't go straight on. They curve off in every which direction. The three main kinds of heat transfer are radiation, conduction, and convection. Radiation heats the surface because the sun's rays give off direct light. Conduction helps heat the first few meters of the troposphere. During convection, the air near the ground is heated up, becoming less dense, and it rises to the top. There, it cools down, becoming more dense and sinks.
Thanks for watching!